There's a lot of solving trig equations videos out there. I thought this semester I'll try recording some of my own because I think I want to point you, direct you some ways to solve these rather than some of those methods people use are way out there. And so here's what I'm going to have you do. This is from section 6.4 in the Lippmann book on page. I picked some odd numbered exercises out of this section starting on page 140, and you're going to see some different kinds of questions. And some of them are going to ask you to solve the equation on uh, 0 to 2 pi, one revolution. Some others will say find all solutions. Some others will say find the first two positive solutions. Math is going to ask you to find the first three positive solutions. And so we'll talk about how I solve these. All right. So um, I've been working with the unit circle for a long time, so I'm very familiar with it. You probably aren't, or maybe you are, but I would certainly grab a copy of this. I've got one linked in Canvas, and you can certainly just Google unit circle. If you get a unit circle, make sure you get one that's got both radians and degrees on it. Okay. So how do we solve this? Well, I want to solve for a variable, and the variable I'm seeing is theta. That's what I'm solving for. But I get this whole argument here that theta, I mean, theta is having the sign, it's a sine of theta is being, we're taking the sine of the angle. So that's all locked up in there. So we got to isolate the sine theta. So what I'm going to do, as you probably can see already, I'm going to divide by 2. That tells me the sine of theta equals negative root 2 over 2. And I'm hoping at this point you say, oh, that's a unit circle number. So let's go take a look at the unit circle. And we're looking for where is the sine of theta, sine of an angle negative, what angles have a sine that's negative square root 2 over 2. So I'm seeing, right there, remember sine is y, because that's the opposite side, and it's on the unit circle, the hypotenuse is 1, so opposite over hypotenuse means it's just the opposite. So that's the value we're looking for. And that angle is 5 pi over 4. So one of the solutions on 0 to 2 pi is 5 pi over 4. We do calculus in radian measures. That's why we're steering you away from degree measure, unless it's an application. I mean, then degrees make perfect sense. But when you're dealing with analytic trig, you want to be working with radians for the most part. Now, the other thing I'm going to ask yourself is maybe that's the only solution, but I don't know if you've seen any of my other videos or seen this in another video. In quadrant 1, all the trig ratios are positive because x is positive and y is positive. And therefore the tangent is positive divided by a positive. So they're all positive. In quadrant 2, only the sine is positive because only the y values are positive. So that would tell me that tangent, because tangent's y over x, it would be negative. Cosine is just the x, so that's negative. And then of course we get the reciprocal functions. Sine and cosecant would be positive. Cosine and secant would be negative here in quadrant 2. And that's why I have an S here. Down here, I'm going to write a T because the only thing that's positive in quadrant 3 is the tangent. Because if you look at the values of the x and y points on that circle, right, according to the circle, that circle, they're both negative. So cosine's negative, sine's negative, but opposite divided by adjacent, or y divided by x, is positive. That's why the tangent and the cotangent will be positive. And then, of course, the only one we haven't talked about, maybe I will just say the x's are positive here, so that means the cosine is positive, and secant. So we're looking for where is the sine equal to negative root 2 over 2, or negative, right? So sine is negative here, sine is negative over here, so there's another answer, and you can see it right there. See that negative root 2 over 2? That tells me 7 pi over 4 is the other solution. So let's see if I can't move that out of the way. So the other solution of 0 to 2 pi is 7 pi over 4. And that's the only two places where the sign is negative on one rotation. Right. Then it always comes up, at least some of my calculus students here at Oxford are having a hard time with this year. I get to drill them is what I'm going to do, but this is when's the sign equal to 1? Well, there's if you think about the unit circle, there's only one place where the sine, which is the y value, is equal to 1. And it's one of these, this is that quadrantial angle, pi over 2. So the only answer on 0 to 2 pi, whoops, don't want to erase that, would be is equal to positive 1 is pi over 2. And I can't write here. There's only one solution on that interval. Okay. So hopefully that helps. All the ones in this first section in the textbook are unit circle questions. So if you haven't memorized them yet, make sure you have your unit circle out. Okay, so what's different about this problem is they're asking us to find all solutions. So, but let's, for the first part of it, let's proceed as we did the other question. So I'm going to divide by 2. So that tells me sine theta equals -1/2, and you might be saying that's a unit circle number. Of course, you probably see my unit circle here. So when does the sine equal -1/2? Well, we know that sine is y, and so we're looking for where's the y equal to 1/2? Well, it's got to be here, because remember, tangent's negative over here, and so tangent's positive. Sine is negative over here, and sine is also negative over here in quadrant 4. So I see an answer of 7 pi over 6. And I see another answer of 11 pi over 6. Those are the two places where the sine's equal to -1/2. So we've got that. Let's come back here. But that just addresses between 0 and 2 pi. So what did I say? 7 pi over 6 and 11 pi over 6. What can happen now is, because we're not limiting it to one rotation, we can go all the way around again. So let me show you what's happening here. I made these Desmos graphs, and this will help you see what's going on, I think. Do I have the right points? So, yes, I do. Just a minute here. And put them on the same graph. So I graphed, here, let me drag both of these over. I graphed these equations. I graphed this equation as two separate functions. I treated them like a system of equations where there's the 2 sine theta, and then y equals -1. That's on the other side. And then we look for where they cross. So I'm seeing, now remember, it's got to be equal to -1. So there's the 11 pi over 6. See that? And then here's the 7 pi over 6. So far I've only dealt with these two answers. But I'm seeing a lot more answers. I'm seeing a solution out at 23 pi over 6. I'm seeing a solution at -pi over 6. I'm seeing a solution at -13 pi over 6, -5 pi over 6, and so on and so forth, okay? So how do they get those? So when you see all solutions, here's what you want to think about. Let me get those out of the way. Move this up if I can. I know that theta equals 7 pi over 6. And then what I got to do to get back, so if we look at the unit circle, we can see this. I'm right here. How do I get back to that answer? Well, I got to go all the way around the circle once. So what I'm going to do is add the period, because sine x or sine theta has a period of 2 pi. I could go around again. So I could add to 4 pi and 6 pi and 8 pi. I could take away 2 pi. So the way we deal with this is just put a k or an n or something there. That tells your readers that, okay, I know the first positive solution is 7 pi over 6, and then I'm going to go all the way around the circle however many times I need to get all the answers. And then the same thing can happen when theta equals 11 pi over 6. We're just going to add the period, because this is a 2 pi period, and then k. So that's what we're looking for when we say all solutions. And here's another all solutions one, but what's different about this is you see how there's an argument, there's that extra there's that pi coefficient inside the argument. So for a minute, we're going to ignore the pi over 6. We're going to do it just like what I did. In fact, if you want, you can try stopping it and see if you can't figure that out using your unit circle. I'm going to continue. So I know that sine of pi over pi theta has to equal positive 1/2. I'm looking at my unit circle. I see that pi over theta equals, let's see, pi over 6 and 60 and not 2. And I see it's also equal to at positive 1/2 at 5 pi over 6. And then because we're looking for all solutions, we got to add that plus 2 pi k, right? Because you can go all the way around again. And the same thing here, plus 2 pi k. Now we've got to deal with this pi. So what we do is we're going to, because I want to know what theta is equal to, not what pi theta is. So I'm going to divide by pi or multiply by 1 over pi. So what happens with that is here, let me get a pointer going. Let me be sure to write this in just in case somebody's a little rusty. I'm going to multiply by 1 over pi, and if I distribute that through, I get 1 over 6 plus 2k. And then same thing here, if I multiply this by 1 over pi to divide out the pi, theta is equal to 5, 6 plus 2k. So that tells me the first solution is at 1/6. The second solution is at 5/6. If they wanted a third solution, I would just add 2. So here, let me write these out. So I know the first solution is 1/6. The second solution is 5/6. If I wanted a third solution, I would take and add 2 because that's the period. That's the period of this function, right? 2 pi divided by pi is 2, so that's where that came from. Okay. So I'm going to add 2 to that. So let's see, 2 is, I could write 2 and 1/6, but 2 is 12/6. So that'd be 13 over 6. Then I'm going to add 2 or 12/6 to 5/6, which is 17 over 6, would be the fourth solution, and I could keep going as many times as I wanted. Okay, so that's how you deal with it when there's an argument inside the parenthesis. So for this one is a weird one because that's not a unit circle number. So we have to resort to a calculator with this one. So on my TI-84, I pressed the second button, hit the sign button, and you get that arc sign notation. And we're going to do arc sign of the answer, and it gave me that interesting. It's very close. That's just a coincidence. So what that told me is here, I've got this first answer. That angle is 0.2734. I'm going to round. But they're looking for 0 to 2 pi, not just one answer. So I've got to ask myself, where is the sign positive? Well, just like before, the sign is positive here in quadrant 2. It just so happens that this angle and this angle is the same. So this is the reference angle. So to get this angle here, I've got to do pi minus the 0.2734. I'm not going to crunch that because that's just a decimal number. You could do that if you wanted to, and it's an odd numbered exercise, so you could look that up. So there's the two answers on 0 to 2 pi, and this has a period of 2 pi, so I know there's only two answers. So here's another equation. This is asking for the first two positive solutions because they aren't specifying in 2 pi. We only need two answers. And I'll show you why in this video. We're going to tackle this just like we did before. We had, I think I had a pi theta. The 6x is just going to be, I'm going to ignore it for a second. I'm going to solve for the sign, which is 2 over 7. Not a nice, neat unit circle number. So I'm going to grab my calculator and I'm going to arc sign it. So that's what my calculator told me. Again, I was in radian mode. So that's one solution. Now they want to do the first two positive solutions. So how do I get the next one? And actually, that's not even the one solution now that they said that because I'm seeing the 6x. So let's look at a graph of this, and then I'll be able to. We're going to take it down the road, show you how to get to all solutions. Now, what I'm seeing is I graph the two equations separately, and I look for the intersections, and I see that the first two positive solutions is there's one there, looks like it's 0.048, which is not equal to what I have. And then the second positive solution is 0.475, which is not what I have. So we're going to decide how they did that. And maybe you already see it. What I didn't deal with is I didn't deal with that 6x. So I've got 6x, let's see, I've got 6x equals 0.2898. I also didn't deal with where is signed a positive number. So we know it's positive over here, which is where is the 7 sign? Where is this equal to a positive number? So right now we know that this angle right here is 0.2898-ish, and it'll have to be the same over here if it's a positive number. So 0.2898. So to get that answer, we're going to do pi minus that number, and I'm just going to do that off screen. Minus that answer, and I'm getting 2 points, so 6x is equal to 2.85. I'm going to go with 2. So that's the two angles so far, and that's on 2 pi. Now we've got to deal with the 6. Now they're just asking for the first two answers, two positive answers, so all I've got to do right now is just divide both of these equations by 6, and you'll see those first two answers that I had on the graph. I'm seeing x equals 0.0483-ish, and then I'm seeing divided by 6, 0.4753-ish. And I don't know if you got a memory, I was just thinking that certainly seems familiar. If I look at this, you can see those, right? There's that first, there's this number right here on the x. We know y is 2. And then you'll see that second number right there on the x. Okay, so there's the first two positive answers. How do I get the next one? How would I get the 1 point, which one was the next one? This one here. How would I get the 1.95? How would I get the 1.523? Well, this is where, if they asked for, My Open Math does this, if they asked you for the first 4 positive solutions, right? Let's see, can I move everything up? What I want to do is I'm going to come back to here. I'm going to say 6x equals 0.2898 plus 2 pi k. And then I'm going to do the same thing over here. I'm going to say 6x equals 2.852 plus 2 pi k. That keeps us going around like we did before. And now I'm just going to divide everything by 6. So x equals, I don't remember, do I still have those on my calculator? I do. 0.0483 plus pi over 3k, right? And x also equals 0.475 plus pi over 3k. So first answer, second answer. If you need a third answer, add pi over 3 to this answer. If you need a fourth answer, add pi over 3 to this answer. If you need a fifth answer, add pi over 3 to that last answer. Okay, and you just can keep going until to your heart's content. So I think that's the end of the problems I picked out. I hope this helps. I encourage you to go into the textbook and try some more of these questions before you jump onto My Open Math, but you certainly can. You know, you don't have to do those, but I think it'll help you out.